going on. Okay, let's started the story based learning process. So first what is array? So array is fixed size collection known as a known at compile time, right? That means we know the size in compile time. And in story, this is the story of Maitra bakery. So Maitra muffin tray is 12. This is fixed slot and cannot add 13, right? Okay, so that is called array, right? So if we want to see here, we can see the example. So Rust array is different from other language arrays. In let's say in JavaScript, we just write the array. This is the array, and here we don't define anything. But in the Rust, we defined what type of array we have in what types we have in the array. So this is the different from other language. So but overall that is not a big change. And vector, so this is a let's say this is dynamic array, right? And this concept is used hugely in Rust. So we have to understand the vector. So what the vector does, what is vector? Vector is growable collection dynamic size. Okay, so in our story we have a display case shelf where she can the Matra can add or remove the add or remove the let's say lovens dynamically. So this can be a cake. We Matra can add and remove cake from shelf dynamically, right? So this is vector vector. So you can see the vector structure. So we use vect new to create a new vector, and we can push the vector in vector anything like integer character or any string, right? So this is the vector, and now we will understand the resizing. So growing and shaking the vector, growing the shaking the vector, growing and shaking the vector, right? So in our explanation we have we explain that the display can display case where she bakes more, explaining the display cake where she bake more, right? So if we don't understand, we should go through the story, what the story said. So resizing, in resizing story, what? So on Sunday the display case is completely full with 50 levels, right? Mitra bakes 20 more. she simply put a leveler on the side of the case, and she shall physically explain to the created two more slot. The levels slide in smoothly. She doesn't have to throw any old levels to make room. Case just grow accommodate the new arrival. The act of making the flexible sheriff larger is resizing. Okay, larger in resizing. Okay, so expanding shell, that means we can change the size, and we can pull a lever. She simply pull a lever on the slide of the case. That means if she want to expand, she just pull the lever and it will expand more. Do you understand what is resizing? This is easy concept. That means we can resize anything, right? In iterator, so this is an important let's say topic for Rust. So we have to understand this topic, why this is important to us. A way to walk through a collection, one item at a time. So that means a way to walk through a collection, one item at a time. That means we have a group of people, and if we want to search a person, we will go through all the person live in the all the person in the room or group, right? So the assistant walk down the display shelf, look at each loaf. Okay, that means iterator mean each. So where we find iterator, that means each. We should go to the example of iterators. So this is vector, and this is vector with capacity, right? It can change it change the capacity to 20, right? Vector automatically resize, but you can also manually resolve the space. So I can tell I can max need 20 or 30 byte, right? But on the other hand, if we want to see the iterator, here you can see the iterator. This is a shelf, and it is a vector, right? So if we want to iterate, so what will happen? We can see one by one. We can see one by one element from the vector, right? So why we use iterator? We use iterator to see an individual item in the vector, right? Vector or array. that is the core concept. Okay, so okay, so here we learn about iterators, but now they are saying iter. So what is the difference between them? At first we should understand what is iter. The specific method that create an iterator. So that means iter is a specific method that is iterate that can create a iterator, right? So basically this is a function. Method is inside the implementation function called method, right? So that's why it is an method, and it create a iterator. It create an iterator, right? So on the other hand we have lifetime. So this is an important topic. We have to understand the lifetime properly. If we don't, we can't understand 70% of coding in Rust, because lifetime use hugely. In the basic level we don't find out the implementation of lifetime, but if we go through the production code, we can understand the importance of lifetime. So what is lifetime? How long a borrow wrapper is valid, ensuring it doesn't outlive the data is point 2. That means the borrow recipe card, it must not throw away while some the borrower receive a card. It must not be thrown away. It must not be thrown away while some is still reading it. That means I just give a let's say billboard a board let's say board to another person, and there is a speech, and I just ask him to just stand with the board. I will read from the board. So in that time the person who are holding the board, he can't throw the board, right? That is the main concept. Okay, so what is going on in the lifetime? First we have to see iterator. What is iterator according to the story? So the next day Matra need another inventory check. Sam asked, how do you want to me work? How do you want me to work? Okay, Matra replied that just use standard working order, start at front and go back one by one. She does not invent new way to work every time. She used to build it reliably method. She used the built-in reliable method, the event shelf and sheriff understand the standard provider standard productivity working method as the iterator method, right? So we have completed iterator, and we should go through the lifetime story. So this is a funny thing to understand. Lifetime. So Mitra has Mitra's hands Sam receive a card to read. She said, you borrow this card for long. So we already understand that a lifetime, right? So mostly lifetime is, let's say one person, I give a board one person, and ask him to take the board like that, take that board. Okay, take that board. We have something in the board that is, sorry, and that is okay. Sorry, that is try to read, that is try to read. We will use this. Okay, try to read. Okay, we give the board, we stand with the board. Here is something right, that is called try to read. So now I am reading the board. Now I just say don't throw this out through the board, because I am reading. So that means lifetime is something like that. You are doing something on on something, and in that time that thing should not be throughout, right? It should be on in your hand. Yes. Okay, so this is what is this? This is lifetime, right? So this is lifetime. What is going on in this? Zero copy oracle institution. Okay. Okay, implement info pyth oracle view. Okay, public. Okay, so that is the lifetime, right? So we implement this in here. So when my program will run, in that time I don't face any issue or problem, right? So that's why we use lifetime. So already you know that this is the lifetime, and we use here as a lifetime. Okay, and second, let's see what is going on next. Lifetime combinator. So this is most used thing in Rust. So we will map, filter, chain operation, everything we can do with the combinator. Now I will just show you raw examples so that you can understand that. combinator. So here you can see lots of combinator with chaining method. This is the chaining method, one by one, one by one, one by one we chain that. Why? First we iterate, then we filter the sound dog, then we use a map for label each of them and collect them into new group. Like that is the collection, and we use chain. You can understand how powerful this is. You can do lots of things in this with this collection, right? Implementation trait. So implementation trait, let's say what is going on. Implementation trait, retain a retrying or an OPQ type that implement the trait without resolving the concrete type, concrete type, right? So in the other hand, if we see the main story concept, that is mystery box delivery, she promised it can print itself, but keep the exit type. Keep the exit type. That means you can easily use implementation trait, but you have to understand the type should be bare or pair, right? On the other hand, implementation 2 use the argument one or more number that bound. So what we are doing here, that is we are understanding implementation trait. So implementation trait use the machine input. It still work, right? So use the machine input, will take anything that can be broken, okay. If we see the examples, then what we'll find. So that is the implementation trait. So that is the implementation trait you can find out here. So let's find out the get settlement state. This is the implementation trait we use here, you can see, and this is display implementation trait, and the output is display implementation trait. Here you can see a string from liquidate and else 220 u20 30 20 30 and 32, sorry 32, right? This is 32. So here we also implement a implementation trait. So different is this is this accept a null function, this accept null function, and this return a implementation trait, right? So on the other hand, if we saw slicer, so slicer is easy to understand, but it we have lots of use in the industry. So what is going on, that is this is the vector. So if I want to know first 3, we just say percentage, it is read-only type, read-only view, shelf, and 0 to 3. That means we have 3 element in the first 3, right? So this is how it going on, and you can see the example here. We take and request first 3, then we have shelf dot I32 and operation I32 operation, that means whether it will came sum or not, right? Okay, so yeah, you can see mutable slice, and we can change it. We can change the element of the array or vector, sorry, of the vector, right? Two state string. So two state string, it is tough to understand, that's why we just go through the story, the reading room versus writing room. So you can have many people reading the menu shared, or one person write on it mutable, but never both at once, right? So if we want to see what is going on in the code, then we can have this out. So this is the concept, two state, that is about two state. So two state means share versus mutable, reader and write, reader and writer, but no both simultaneously. That means we can't use them simultaneously. We have to either one that is one owner, and if you want to change, you will have one owner. If you want to just read, you can read multiple times or multiple owner, right? So here the index trait for reading by the third bracket, right? So here you can see we are reading, sorry, this is called index trait, right? Index trait. This is the index trait, and we push the index inside this with third bracket, right? Okay, so index straight is read by third bracket, and index mute read by third bracket. Okay, so index mute. Okay, index mute. So we can change now. We can change the value of the index, right? That is the work of mutability, right? That is the main concept of index mutable. Hash map and byte map. Hash map, if we understand the hash map under rolled key value store, fast lookup or not ordering. Here you can see hash map. This have a key value store, so that means we have key and value store in hash map. That means we have, here you can see we have a key and the value, that is hash map. And byte tree map, sorry, this is byte tree map. Order key and value, that is sorted key and difference range of queries for byte tree map. And hash map is unordered key store and fast lookup, no ordering, right? So here you can see this is the hash map and we have no order in here. So which topic you face that this is I don't understand why this index or index mute use. So if we want to go to the story, index straight, the inventory card slot 5 gate inventory card slot fast 5 gate the fifth item. So the inventory card slot 5 gate you have the first item. The inventory card slot 5 can new value let replace it, let you replace it. Okay, so hash map is an, let's say this is an ingredient locator, and byte tree map is schedule the drivers, quick to find flower price by name, sort by time, so she can see the next arrival instant. Okay, that is a good thing. So indexer and multi-indexer trait we don't understand, right? So let's see the story. So Mitra labels every slot of the display case with a name number, slot A, slot 1, slot 2, slot 3, and so on, where when Sam said give me the loaf in slot 7. Mitra simply reach into the number slot and put the loaf that ability to direct grip an item by its named position is the index. Iterator read by the position. Okay. We have 3 slots, so when Sam say give me slot 7, Mitra simply reach out the number of slot put out in loaf, and this ability to direct grab an item by its number position is the indexer. That means we have a display with the number display case with the number, and here we can see lots of items, and let's say one of the index 7, and if Sam says give me slot 7, it will go to data structure and find out the 7, right? Replace so this is the same. Find out the 7. Yes, I just find out the 7, and replace the current loaf with the fresh one. So okay, that means she also give me an instruction that you can write smart contract, but if you have don't have sorry if you have the number, you can easily find out or replace by mutable indexer and search by indexer trait, right? So this is the concept we face difficult, right? So if you want this slide what we just built, I can give you just a comment that comment we need. Okay, if you comment we need, then I will give you total architecture what we just use in this video, right? So this is the core concept, like we describe from beginner perspective, right? As a beginner should understand that is the core concept, and those concepts I have to understand. So yeah, that is end of this video, and thank you everyone who watch this video. Bye.